welcome back. This is notes 2C. This should have been the day 38 folder. Welcome. First thing I want you to do is fill in the quick review at the top. You've got a word bank down here at the bottom. Pause. Figure it out. At least try to figure out a couple of them. I'm going to challenge you to figure out at least 4, 5. Figure out 5 on your own and then come back. Okay, here we go. Substances that are acids produce hydrogen ions in water, and this is expressed by writing H+. Substances that are bases produce hydroxide ions in water, and that's expressed by writing OH negative. Remember boy bands, O, and I hate boy bands, and that's negative. Acids have a pH of 0 to 6. Bases have a pH of 8 to 14. Neutral substances have a pH of 7. And then we calculate density with the equation of density equals mass over volume. The way to remember that, where do you go to get your density license? At the DMV. DMV is where we go to get our density license. Get it? Okay. Moving along. Okay, so it says yesterday, but of course we know that with the crazy world we're in that it wasn't yesterday. So last time, we wrote down a lot of chemical formulas for acids and bases. But what do they mean? Let's look more closely. So sugar, glucose, what we talked about in the lab, plant sugar is C6H12O6. Well, what does that mean? The letters tell us the name of the element. So the letter is the chemical symbol of whatever element is in the compound. And then the numbers tell us the number of atoms of each element that are in one molecule of that compound. These numbers are called subscripts because they are under the letter. Subscript, under the letter. So the elements in sugar are C, H, and O. Carbon, hydrogen, and oxygen. So now I want you to look at the number of atoms of each element in one molecule of sugar. So we know the names of the elements are carbon, hydrogen, and oxygen. So now to know the number of atoms of each element in one molecule of sugar, we have to look at the subscripts. So C is 6, H is 12, and O is 6. If there is no subscript, so like in H2O, there's no subscript here, it's empty. Well, does that mean there's none? Well, of course not. If it meant there was none, it wouldn't be there at all. The fact that it's there with no subscript means 1. So when there's no subscript, the number of atoms in that element is 1. Pause if you need to. So salt. The chemical formula for salt is NaCl. NaCl. Alert, alert. You need to know that one. Alert, alert. There are no subscripts in this formula. So there's no number here. There's no number here. So what does that mean? That means there is 1 atom of each element to make 1 molecule of salt. You need 1 sodium and 1 chlorine to make 1 molecule of salt. So now I want you to look at these 8. I want you to tell me the element and how many atoms of that element are in each one. Okay? I myself am going to pause the recording, write the answers down, and then unpause just long enough for it to be in the video, and then move on so that we don't eat up a whole bunch of video time with just me writing down answers when you're supposed to be doing them on your own anyway and just checking yourself. So that's all I want you to do. All right, work on it. All right, so there are all the answers. I want to draw your attention especially to number 6, because in that one you've got magnesium hydroxide, but you got parentheses and then 2 on the outside. And just like in math, that 2 applies to everything within the parentheses. So it will be magnesium 1, oxygen 2, hydrogen 2 for that one. And then I also want you to pay attention to, well, which things are organic here. So we know that aspirin and caffeine are both organic. Why? Because they have those carbon-hydrogen bonds. All righty. You're going to pause it so that you can check yours. I'm moving on. My handwriting's not the best when I'm doing this. I've noticed. Much better, when I'm not brushing. All right, so what's the difference between a chemical formula and a chemical equation? Equations show a reaction or interaction between more than one compound. A chemical formula is just one compound. It's like the recipe for how to make one atom, one molecule of that compound. But a chemical equation, I get a compound plus a compound and then an arrow, and that arrow shows that a reaction has taken place. That arrow is not an equal sign. It means that something magical has happened and things have changed. And then there's going to be more compounds or single elements on the other side. So here, this is the unbalanced chemical equation for photosynthesis. So we've got CO2, which is one of the ones you're supposed to know. That's right, carbon dioxide. Someone knew that. If you don't know that CO2 is carbon dioxide, please make a note to yourself that CO2 is carbon dioxide. And then H2O is, of course, water. And again, if you don't know that H2O is water, then you need to make yourself a note of that. Now, we know that that's what plants need: carbon dioxide and water, and then energy from the sun. And then we have our arrow showing that a reaction is taking place. And we have C6H12O6, which we already discussed is sugar. That's right. It's glucose, simple plant sugar. And then O2 is, of course, oxygen gas, right? Air. So that's what plants produce. They make sugar for themselves and they release a little bit of oxygen gas. Now, what's awesome is that no matter whether you knew what those compounds were or not, you still could have told me what are the reactants and what are the products. For photosynthesis, you know what a plant needs. That's the reactants. So everything on the left of the arrow are the reactants, the things needed for the chemical reaction to take place. And then everything on the right of the arrow, so the things that the plant makes, sugar and oxygen, are the products. It's what is being produced. So reactants react, and the products are the product. The product is produced by the reaction of the reactants. So, like I said, no matter how simple or complicated, you can figure out what are the reactants and the products, because everything on the left is the reactants. Everything on the right is the products. So for this section, I want you to look at the given chemical equation and then break it up into the reactants and the products. Now, do you have to know what the stuff is? Of course you don't. You just have to know that everything on the left is the reactants and everything on the right is the products. I'm going to do the first one with you. Do it together, and then you can do the rest of them on your own. And again, you're just going to need to come back to check your answers, because I'm going to pause the recording while I write down the answers, and the answers will just be up there for a second. So make sure you pause the video. So here's our arrow right here. So this is what I need to write on my reactant side. Na3PO4 plus 3KOH. Now, I know that that means sodium phosphate plus potassium hydroxide. But do you have to know that to be able to answer this question? Nope. All right, products is everything on the right side of the arrow. So that's everything on this side. So over here in the products, 3NaOH plus K3PO4. So that's 3 sodium hydroxides plus potassium phosphate But again, do you have to know that? Nope. You just have to know what's on the left side of the arrow, what's on the right side of the arrow. Okay, I'm going to fill in the rest of them. You are too. Pause your video and then come back to check your answers. All right, so here are the rest of the answers. We've got a replacement reaction here where they're just switching each other. We've got a decomposition reaction here where our one big compound breaks down. We've got a combustion reaction here. We know that because the products are carbon dioxide and water, and that's always the products of a combustion reaction. And we have another decomposition reaction here where the two NOs are breaking down. Check yours. Moving on. So now that we know what a chemical equation is and how to identify its reactants and products, we need to learn how to balance them. Just like on the scales of justice, there need to be equal numbers of atoms of each element on each side of the equation for it to be balanced. Matter can be neither created nor destroyed. So if I have gold on one side, I've got to have gold on the other side. This is why alchemy wasn't really possible. They were trying to make gold an element out of other elements. And unless you're going to start throwing protons at something, we can't really do that. So earlier, we looked at the unbalanced equation for photosynthesis. Carbon dioxide plus water plus equals energy from the sun, plus energy from the sun results in sugar and oxygen. So is that balanced? Well, let's see. All right, if we draw a line there under the arrow and we write in carbon, hydrogen, oxygen, just so we can count how many atoms of each we have. Over here we have 1 carbon, 2 hydrogens, and 3 oxygens. 1 carbon because there's not a subscript, 2 hydrogens because it's H2, and O3 because there's 2 oxygens here and 1 there for a total of 3. Carbon here, we have 6, H12, and then oxygen, we've got 6 here and 2 here for a total of 8. So is that balanced? Do we have equal numbers of the atoms on each side? That's a big no. So what in the world do we do? You can't add atoms of individual elements because that will change what the compound is. So for example, I can't, with the CO2, just put a 6 there. And, it's balanced now, right? No, because C6O2 is something else, or it's nothing. I'm not sure. Probably it's not anything, but it's definitely not carbon dioxide. It's something else. And we need carbon dioxide. So you can't change the number of carbons, but you can change the number of carbon dioxide atoms so that you get more carbons. So what we do is increase the number of molecules of certain compounds until we have a balance. So the first thing you've got to do is do what we just did. Write down CHO, CHO, and we had 1, 2, 3, and 6, 12, 8. So now we look at how many we have over here, and that's going to help us figure out how many we need over here. So I need 6 carbons, so I'm going to put a coefficient. Just like in math, when I've got A, B, and then there's a 2 in front of it, the coefficient, and that coefficient multiplies by both things, same thing is happening here. So I now have 6 carbons, but I also have 12 oxygens. I'm not done yet. I still need to get 12 hydrogens, right? So what coefficient can we put here that multiplies times 2 to give us 12? Well, in other words, what times 2 equals 12? 12 divided by 2 equals 6. So 6. So that's going to give me my 12 hydrogens, and it's also going to give me 6 times 2 is 12 oxygens plus 6 from that one. So 12 plus 6 equals 18 total oxygens. So now I've got to get 18 oxygens over here. Now, it's very tempting to just put a 9 right there because 9 times 2 is 18. But that would be wrong because you've got oxygen right here that you need to account for. So we know we need 18, and we know we've already got 6 covered right here. So 18 minus 6 is 12. So we need this to be 12 oxygens. And what number was that that's going to give us that? Exactly, 6. So the balanced chemical equation for photosynthesis is 6 carbon dioxide plus 6 water plus energy from the sun results in 1 sugar and 6 oxygens. So a way to remember that, sugar is evil, 666, right? Or photosynthesis is evil. Respiration is evil because respiration is just this backwards. But anyway, 666. The magical number to balance photosynthesis is 6. That large number is the coefficient, and it tells you the number of molecules of that compound are involved in the equation. And just so we don't forget, coefficient, add that to your notes. You need to know that's the coefficient. All right, we're going to look at one more. Hint, hint, test, question, alert, okay? This will be the one that's on the next quick quiz. Then we're going to spend some time on stoichiometry, which is what this is, balancing chemical equations. We're going to spend some serious time balancing chemical equations, and then we'll have a balancing chemical equations quiz. So the only one that you've got to know for the upcoming quiz is this one right here. Hint, hint, hint. The other quiz that you also have coming up is the first 18 elements and their symbols. And there is a Quizlet posted in the folder today to help you review those in case you need some review with those. All right, so this is the one that's going to be on the quiz, so let's do it. Step number 1, draw a line underneath it that divides the reactants and the products. Step number 2, identify your elements. We've got aluminum and oxygen. Aluminum and oxygen. Step number 3, identify how many atoms of each element you have on each side. So aluminum on this side's 2 and oxygen 3. Over here, aluminum 1 and oxygen 2. So now we've got to get everything balanced. I know that I need 3 oxygens. I'm not going to be able to make 2 equal to 3, but where do 2 and 3 cross? 6. 2 times 3 is 6. So I'm going to shoot for trying to get 6 oxygens here. So 3 times 2 is 6. Now that gives me 6 oxygens. So that means I got to go back over here and get 6 oxygens over here. So what times 3 will equal 6? 2. So I'm going to put a 2 there. And that gives me my 6 oxygens. But oxygen isn't the only thing that changed there. There's aluminum in that formula as well. So I've also got to take that into account. 2 times 2 is 4. So I have 4 aluminums. So now I got to come back over here. This needs to be a 4 so that it's all balanced out. I now have 4 aluminums on both sides and 6 oxygens on both sides. Now, that is the only one of these that's on the quiz. Hint, hint, okay? Then we'll take the quiz, it's Quick Quiz 5. We'll take that quiz, and then we're going to spend a lot of time on stoichiometry, and you'll be much more comfortable with it. All right, so that is it. Have a lovely day. Make good decisions. Bye.